Hello. If you were tasked with building a global research empire from your living room, would you start by buying a fleet of physical servers, or would you simply rent the brainpower of the universe? Today the choice is obvious. The answer is cloud computing, yet the mechanics behind that choice are often misunderstood. Cloud computing is not just someone else's computer. It is a fundamental shift in how humanity scales its intelligence. To understand this shift, we must look to the framework of NIST, National Institute of Standards and Technology, which serves as the DNA of the modern cloud. 1. On-demand self-service. The no-permission revolution. In the traditional workplace or university IT model, if you needed a high-performance server for a weekend project, you'd be filling out forms and waiting weeks for a sysadmin to rack a physical box. Cloud computing kills this bureaucracy. On-demand self-service means you are the captain now. Whether it's 2 a.m. on a Sunday or right before a thesis deadline, you can spin up a virtual supercomputer unilaterally. It's like a vending machine for CPU power. You click a button, and the resources appear without you ever having to speak to a human being or explain your life choices to the IT department. 2. Broad network access. The death of the work computer. We've all had that nightmare. You have a breakthrough in your research, but the data are trapped on a workstation in a locked office, and you are traveling in a foreign country. No problem. Broad network access ensures that the where and what of your hardware no longer matter. Now you can access your data even while lounging on the beaches of Bora Bora. Caution. From now on, you have no excuse not to work during vacation. Whether you are accessing your neural network from a high-end desktop, a tablet at a conference, or even a smartphone while waiting for coffee, the experience is identical. The cloud speaks every digital language, mobile, web, thin client, essentially turning any screen with an internet connection into a portal to your entire research infrastructure. 3. Resource pooling. The great computing commute. Think of the cloud less like a private car and more like a high-speed rail system. Resource pooling allows the provider to serve a massive multi-tenant audience by dynamically shifting resources where they are needed most. Behind the curtain, you might be sharing physical hardware with a startup in Berlin or a gamer in Tokyo, but the virtualization layer keeps you invisible to one another. It's an elegant shell game. The provider moves blocks of power around so efficiently that everyone feels like they have the entire data center to themselves. 4. Rapid elasticity. The accordion effect. For most users, computing needs aren't a flat line. They are a series of panic spikes. One week you're just checking emails. The next, you're training a massive LLM that needs 100 GPUs. Rapid elasticity is the cloud's ability to breathe. It scales outward like an accordion when you need to crunch big data and snaps back to almost zero when you're done. To the user, it feels like having an infinitely deep pocket. You can pull out as much power as you want, whenever you want, and you never have to worry about running out of internet. 5. Measured service. The utility bill mindset. Finally, the cloud operates on the Starbucks model. You don't pay for the whole store. You just pay for the latte you drank. Measured service provides absolute transparency by metering your usage down to the millisecond or the gigabyte. This pay-as-you-go approach is what makes high-level AI research accessible to individuals rather than just giant corporations. It treats computing like a utility, similar to your water or electricity bill. You get a detailed receipt showing exactly what you used, allowing you to optimize your budget and ensure you aren't paying for a parked server that isn't doing any work. Conclusion. By mastering these 5 NIST characteristics, you aren't just learning technical definitions. You're learning the architecture of the modern world. These pillars, automation, accessibility, efficiency, scalability, and accountability, are what allowed small research teams to build the large language models and AI breakthroughs we see today. What do you think? Has the cloud fundamentally changed the way you approach computing? Or do you still find yourself wishing for a dedicated physical workstation? Please share your thoughts in the comments below, and don't forget to like and share this video if you found it helpful. Thank you for watching. Goodbye.